I think we can expand this since we're done with the example. Trade-offs of the state pattern. We've shown that Rust is capable of implementing the object-oriented state pattern to encapsulate the different kinds of behavior a post should have in each state. The method on posts know nothing about the various behaviors. The way we organize the code, we have to look in only one place to know the different ways a published post can behave. The implementation of the state trait on the published struct. So they're just summarizing what we did and how we went about implementing the state pattern in the ways that the state pattern should be implemented. All the associated code for each state is associated with that specific state. Whew. Good job. Good job. That was impressive and kind of heavy, but impressive. If we were to create an alternative implementation that didn't use a state pattern, we might instead use match expressions in the methods on post or even in the main code that checks the state of the post and changes behavior in those places. That would mean we would have to look in several places to understand all the implications of a post being in the published state. This would only increase the more states we added. Each of those match expressions would need another arm. So here, you're going over if we were to use a different implementation. Let's say we didn't use the state pattern. And if we're not using the state pattern, and we have these different variations of like draft, publish, review, and published, right? Anytime we needed our code to function differently, we might use a match expression. And then we have a default 3 different arms. And we need that for every method. We will need that for review. What was it called? Go up real quick. We'll need the match expression for request review. We will need it for approve. And we'll need it for content. And then anytime we added a new state, we would have to add a new arm. So some of the downfalls of this is that in order to understand one specific state, we need to go to different places of the code and then reference how we treat that state in those places. And if we wanted to add a new state, each of those places that has a matching expression will need a new arm. With the state pattern, the post methods and the places we use posts don't need match expressions. And to add a new state, we only need to add a new struct and implement these trait methods on that one struct. Yep. The implementation using the state pattern is easy to extend to add more functionality. To see the simplicity of maintaining code that uses the state pattern, try a few of these suggestions. Add a reject method that changes the post state from pending review back to draft. Require 2 calls to approve before the state can be changed to published. Allow users to add text content only when a post is in the draft state. Hint, have the state object responsible for what might change about the content, but not responsible for modifying the post. I see. So here they're saying if we want to see the simplicity of changing and maintaining the state pattern implementation of this code, we can try doing these things. So we added a reject method, right? The reject method would seemingly be added to the state trait, and then we would just have to, we can give it a default implementation if we wanted to, but the implementation for pending review could just go all the way back to the state draft, and we're only changing that in one place seemingly. And then if we wanted to do something like require 2 calls to approve before the state can be changed to publish, that one seems a little bit trickier because we have to save state, and I'm not sure where the call count for the state is going to be saved, but we would add that implementation would seemingly just be added to the pending review state, and then there somehow we would keep track of how many times approve was called, and if it was called twice, then we can move it to the next state. And then the third one was allow users to add text content only when a post is in the draft state. So for this one, it looks like this is probably similar to the content method that we have on the trait state, in the sense that content is a method on the trait, and now each state implements that method. So for add text, we would add text to the trait list of methods, and then each state is going to have an add text method associated with it, and then the default ones would not allow it to add content to the content internal post, but the draft state would have it. But in summary, with all of these changes are mostly localized in the states themselves, and the state is responsible for everything needed for that specific state. So maintaining it does look kind of cool. One downside of the state pattern is that because the states implement the transition between states, some of the states are coupled to each other. If we add another state between pending review and published, such as scheduled, we would have to change the code in pending review to transition to scheduled instead. It would be less work if pending review didn't need to change with the addition of a new state, but that would mean switching to another design pattern. Alright, so one of the downsides they're mentioning here is that if you ever have to add a state in between the existing states, that can be a pain, because now you're actually changing some of the internal works of each of those states. Another downside is that we've duplicated some logic. To eliminate some of the duplication, we might try to make default implementations for the request, review, and approve methods on the state trait that return self. However, this would violate object safety because the trait doesn't know what the concrete self would be exactly. We want to be able to use state as a trait object, so we need its method to be object safe. Okay, this downside makes a lot of sense as well. We have a lot of duplicated code. So let me just go back to the code itself. For example, pending review has a request review and a return self. Publish also has the same method and a return self. This is the exact same logic duplicated in two places. Most times, if we want to try to remove duplicated logic, we will centralize it in the one place it all gets it from. Make a default implementation on the state trait itself, which is here. But in this case, we can't do that because these methods return self. And to make this trait a trait object, to make it eligible to be a trait object, it's up here. None of these methods can return self, which is a concrete type. Other duplication includes the similar implementations of the request, review, and approve methods on post. Both methods delegate to the implementation of the same method on the value in the state field of option and set the new value of the state field to the result. If we had a lot of methods on post that follow this pattern, we might consider defining a macro to eliminate the repetition. See the macro section in chapter 19, which we haven't gotten to yet because we're in chapter 17. By implementing the state pattern exactly as is defined for object-oriented languages, we're not taking as full advantage of Rust's strengths as we could. Let's look at some changes we could make to the blog crate that can make invalid states and transitions into compile time errors. Okay. So what they're stating here is that another duplication is the weird pattern we have of taking the, here I can show you real quick. Where is it? this pattern right here, where we take the inner state of the option, like we use self.state.take to replace it with none to do the switcheroo, and then we replace it with some value. This is duplicated here, here, and if we had a bunch of other different methods, it would happen a lot more times. And this duplication, looking at it, it's kind of annoying, especially if you had like 10 of them. But when you're using the state pattern as defined strictly, or if you're using the state pattern as you would typically use it with object-oriented languages, then you cannot avoid this duplication. Well, I guess technically speaking, you could avoid that duplication if you use macros, but we haven't learned macros yet, so as for now, you're stuck with that duplication. And then here, they're saying that writing the state pattern in this manner doesn't take full advantage of Rust's strengths as a language. And from this point on, we're going to look at some of the things that we can change to make these transitions into compile time errors. Okay? Encoding state and behaviors as types. We'll show you how to rethink the state pattern to get a different set of trade-offs. Rather than encapsulating the states and transitions completely so outside code has no knowledge of them, we'll encode these states into different types. Consequently, Rust's types checking system will prevent attempts to use draft posts where only published posts are allowed by issuing a compile error. Let's consider the first part of main enlisting 17-11. So it looks like we're starting over. So we have the new post, and we have add text, and we have content. So we're trying to redo this now. We still enable the creation of new posts in the draft state using post new and the ability to add text to the post content. But instead of having a content method on a draft post that returns an empty string, we'll make it so draft posts don't have the content method at all. That way, if we try to get a draft post content, we'll get a compile error telling us the method doesn't exist. As a result, it will be impossible for us to accidentally display draft post content in production because the code won't even compile. Listing 17-19 shows the definition of a post struct and a draft post struct as well as methods on each. Alright, so now we're rewriting this. So we have post, which still has content string. We have draft post, which is a new struct. There is no trait here, so we're not using trait objects. And in post, we have new, and it's going to return the draft post, content string. And post also has content, which returns a reference to the inner string of content. And then an implementation block of draft post. We have add text, which pushes string to the content. But this struct implementation block does not have content. So if we try to call .content on it, it will error out at compile time, which makes sense, which is what they were stating here. So you couldn't do this. Both the post and draft post structs have a private content field that stores the blog post text. The struct no longer have the state field because we're moving the encoding of the state to the types of the structs. The post struct will represent a published post, and it has a content method that returns the content. So let's go back up and look at it again. So yeah, post has content, and draft post also has content. And post has a way of returning it, but draft post doesn't, which we stated earlier. Cool. We still have a post new function, but instead of returning an instance of post, it returns an instance of draft post. Because content is private and there aren't any functions that return post, it is not possible to create an instance of post right now, which is true. So they're stating here is that in terms of this code, right, we create a new post, which actually returned a draft post. And we know that post has a way of returning the content of the string, but currently, based on our API, we have no way of returning a post struct. We just can't. The draft post struct has an add text method, so we can add text to content as before, but note that the draft post does not have a content method defined. So now the program ensures all posts start as draft posts, and draft posts don't have their content available for display. Any attempt to get around these constraints will result in a compile error. Implementing transitions as transformations into different types. So how do we get a published post? We want to enforce the rule that a draft post has to be reviewed and approved before it can be published. A post in the pending review state should still not display any content. Let's implement those constraints by adding another struct. Pending review post, defining the request review method on a draft post to return a pending review post, and defining an approve method on pending review post to return a post, as shown in listing 17 as 20. Okay, so what we're doing now is we're filling out the implementation for the API. Draft post is now going to have a request review, which is going to return a pending review post, and the content is going to be equal to the content that was saved during the draft. That makes sense. The pending review post has the private field content, which we're just transferring data to it. And this pending review post, the implementation block only has approve. And if you call approved, then it returns a post and it transfers the content from its internal state to post. I see. So another thing this means is that for pending review, you cannot call request review because that doesn't exist. And you cannot call add text on because that doesn't exist. The only thing that is valid for a pending review in terms of calling is approve. You get a post back, and on post, you have a way of calling content, the method, to get the internal content of this string. So that makes sense. And it's much smaller in terms of implementations, and it's a compile time error. So if you do anything wrong, you know immediately. So yeah, this is probably the way you should write it. The request review and approve methods take ownership of self, thus consuming the draft post and pending review post instances and transforming them into a pending review post and a published post, respectively. This way, we won't have any lingering draft post instances after we called request review on them, and so forth. So this, I think I skipped over earlier, but let's look at it real quick. So what they're stating here is that we have to note that this is self, as in it's taking ownership of itself and then returning this new thing. So because it takes ownership of itself and then it gets dropped at the end of here, at the end of the scope, these are no longer lingering. So once you make the transition from a draft post to a pending review post, draft post is gone. Similarly, when you make the transition from a pending review post to post, that pending review post is now gone. The pending review post struct doesn't have a content method defined on it, so attempting to read its content results in a compile error, as with draft post. Because the only way to get a published post instance that does have a content method defined is to call the approve method on a pending review post, and the only way to get a pending review post is to call a request review method on a draft post, we've now encoded the blog post workflow into the type system. So yeah, after writing this portion, we have created everything we needed to replicate the code in listing 17-11 outside of the compile time errors that you would get for calling methods that don't exist on these structs. But the workflow, the essence of the workflow is there. But we also have to make some small changes to main. The request review and approve methods return new instances rather than modifying the struct they called on. So we need to add more let post equal shadowing assignments to save the return instances. We also can't have the assertions about the draft and pending review post content be empty strings, nor do we need them. We can't compile code that tries to use the content of posts in those states any longer. The updated code in main is shown in listing 17-21. So we already mentioned that we had to get rid of the asserts. What I didn't mention is the let post, the shadowing assignments. Like they said, since we're returning new instances of structs, we have to assign them, and thus we have to use the let. So here we have let mutable post new. It's mutable because we're changing state internally. We're adding the text to the inner field of content. That's why this is mutable. These don't change the inner state of the content, so they can just be immutable references. So let post, and this is going from draft. This is the draft post. This is going to pending review, which is immutable, and then going from pending review to published is also immutable, and then we can just get a reference to the internal state. The changes we need to make to main to reassign posts mean that this implementation doesn't quite follow the object-oriented state pattern anymore. The transformations between the states are no longer encapsulated entirely within the post implementation. However, our gain is that invalid states are now impossible because of the type system and the type checking that happens at compile time. This ensures that certain bugs, such as display of the content of an unpublished post, will be discovered before they make it to production. Try the tasks suggested for additional requirements that we mentioned at the start of the section on the blog crate, as it is after listing 17-20, to see what you think about the design of this version of the code. Note that some of the tasks might be completed already in this design. So here they're just mentioning like the subtle differences. We've implemented the core of the functionality of the workflow that we wanted. However, it is very different from the state pattern. Some of the advantages that we have in this method is that any errors that, like trying to get the content prior to being in a published state, that is now a compile time error. So there is 100% chance that we will catch those errors well before production. However, with the state pattern, given that those are all runtime checks, it is possible that we push production and then find out we have an issue with something of that nature. Then here, I believe what they're telling me is to go back and do the suggested changes for the state pattern, but do it for this pattern and see how it works out. I'm not going to do that, but I think that's what they're telling us to do here. So next paragraph. We've seen that even though Rust is capable of implementing object-oriented design patterns, other patterns such as encoding state into the type system are also available in Rust. These patterns have different trade-offs. Although you might be very familiar with object-oriented patterns, rethinking the problem to take advantage of Rust features can provide benefits, such as preventing some bugs at compile time. Object-oriented patterns won't always be the best solution in Rust due to certain features, like ownership, that object-oriented languages don't have. So here, they're just telling us to be open-minded. A lot of programmers, me, myself included, we come from a world where we learned all about object-oriented design. We know those are familiar to us. Those are ingrained in our thinking in terms of how we design things. However, in terms of Rust, that may not always be the best way to go about implementing your code. And it seems as though the authors of this book are just asking us to take a step back and think about how we want to implement our code and whether or not we want to use those object-oriented design patterns. Because depending on the problem, they might not be the best for us in terms of implementation solutions. So just take a moment to think. Summary. No matter whether or not you think Rust is an object-oriented language after reading this chapter, you now know that you can use trait objects to get some object-oriented features in Rust. Dynamic dispatch can give your code some flexibility in exchange for a bit of runtime performance. You can use this flexibility to implement object-oriented patterns that can help your code's maintainability. Rust also has other features like ownership that object-oriented languages don't have. An object-oriented pattern won't always be the best way to take advantage of Rust's strengths, but is an available option. Next, we'll look at patterns, which are another of Rust's features that enable lots of flexibility. We've looked at them briefly throughout the book, but we haven't seen their full capabilities yet. Let's go. And that is the end of the object-oriented section of the Rust programming language book. Oh, that was heavy. That was much heavier than I thought it would be. I thought it was just going to be something light, something easy, something that we already covered in detail, and they're just rehashing it. But no, that was a lot. If you liked the video, hit like, subscribe. Aside of that, see you next time. Peace.